This is your Chapter 8 test that we took, and in preparation for the retake, I'm going to walk through the problems here so you can see how to solve these. Your retake will be very similar to this. If you would like to improve your score, I suggest you try to take it. So let's do problem number 1 here, or problem 5 as it was listed. They tell us right away that SOP, so this first triangle, is similar, not congruent, but similar to the second triangle, GNQ. Find the value of x. So all the sides, because these triangles are similar, have to be in the same proportion. So SO, see how that's labeled first, has to be in proportion to GN. Let's mark those. I should mark those both in gray. So those have to be in the same ratio, I should say, as OP. Let's do that one. That's your second pair, is to NQ, this pair, and then our third pair. So the grays have to be in the same proportion as the reds as the purples do, or bluish colors do. So it doesn't matter how you set up your ratio here. I'm going to set up OS, the first gray one. Let's do it in kind of the gray color, to the small gray one, and Q, so big triangles gray side to little triangles gray side, has to be equal to big triangles purple side, SP, to little triangles purple side, GQ. Then we just have to substitute in and solve with a little cross multiplication. So 39 is to 26 as x, and GQ is to 22. Now I would simplify the fraction on the left-hand side first before I did any math. Both divisible by 13. So that's 3/2 equals x over 22. Now I would cross multiply. 2 times x equals 3 times 22, and divide by 2. So x is 33. Second question. In this diagram, we have similar quadrilaterals again. Find the ratio of perimeters. Well, the ratio of perimeters goes exactly as the same as the ratio of sides. So they've told us, for example, they told me side AB, that's the first two, so that would be in the same proportion to WX, like that. So whatever that ratio is would be the same as the ratio of all the other sides, and it'd also be the ratio of the perimeters, because perimeter goes with that scale factor as well. So let's write our scale factor as little quadrilateral side over big quadrilateral side. So it's in the ratio divisible by 9 of 2 to 5. And so that would be their perimeters as well, the ratio of 2 to 5. Now, if you're going from the big triangle to the small triangle, you would multiply by 2/5 to get the correct size. If you were going in the reverse direction from small to big, you'd have to multiply by the reciprocal 5 over 2 and use that scale factor. Well, since they don't have 2 over 5 listed as our choices, they must be using the scale factor of 5 to 2. And that's also the ratio of their perimeters. So the perimeter of the big, instead of using big, I will use its formal name, x, or W, x, y, z, over the perimeter of the little one, a, b, c, d, would be in the ratio of 5 to 2. The perimeters are, as well as the sides. The area is given for the big one. Find the area of ABC. Well, let's first find the scale factor. Okay, and I'm going to use 12 over 60. Both divisible by 12, so it's 1/5 the scale factor is. Now that's also the factor I'd use if I was doing perimeter, but I'm doing area. So for area, the area of the small one over the area of the big triangle would be not 1 to 5. Area goes with the square of that ratio, so it'd be 1/25 as much. So they've told me the area of the big triangle is 1200. So if I take it times 1/25, it will give me the area of the small triangle. So we just have to take 1200 and divide it by 25 essentially. So that goes in there 48 times, I think. Let's see, then you'd need 8 of those. Yeah, so 48 I believe it comes out to, and that would be inches squared. Make sure once you find the ratio of the sides, you have to square it to find the ratio of areas. Find the scale factor from one triangle to the other one. Just make sure you get the corresponding sides set up with the corresponding sides. So we've got, let's see here, FQ, and it goes with CV, so that's this pair. And then we've got QX goes with VI, so there's QX, it goes with VI. And then, of course, that forces the pink ones here. So those are our corresponding sides, purple with purple, green to green, and pink to pink. And we don't know if we're going from small triangle to big triangle or vice versa. So I'm just going to set up a scale factor with, let's do 28 over 35, the blue ones. Both divisible by 7, so 7. Divide by 7, you get 4/5. You could check a few of the other ones. If you did the pink ones, for example, 24 to 30, both divisible by 6. It comes out to 4/5. And if you did the green ones, 36 over 45, both divisible by 9, 4/5. So your scale factor is 4/5 if you're going from big to small. If you're going from small to big, it'd be the reverse of that, 5/4. So that would be our scale factor. Match the congruent angles. Well, you're just going to use, when they make their triangle congruency statement, they tell you who everybody matches up with. You can see that F is the first angle's congruent, so angle F would be congruent to angle C. And then your second one, so the Q goes with V, so angle Q is congruent to angle V. And then your last one's X's and I, so angle X is congruent to angle I. So if you're filling out this chart, what F goes with C, Q goes with V, and X goes with I, like so. What's the ratio of the corresponding side lengths in a state of proportion? Oh, in a statement proportionality, that should read. In other words, they just want you to write the proportionality statement. So let's match up our sides. Now, the easiest way to match up sides, they've also told us the names up here. So FQ goes with CV, FQ goes with CV, and we can see QX goes with VI, QX with VI, and then your last sides down there must correspond to each other. And so let's just write these. We'll go with the pink. So I'll go see what they put on top here. Here they've put CVs on top. So I'm going to do the big sides in pink here. So I'll do the CV, must go with QF. And that'd be equal to the same ratio of my bluish side. So that'd be VI to QX. And that'd be the same as those red sides, but that'd be CI for the big red over FX, the red from the smaller triangle. So CV over QF, CV over FQ, that's the same thing. Same here. So there's CV, nope, not that one. Yeah, it is. So here's the only two that have CV over QF or FQ. It's got to be one of these two. Then I got VI over QX. Oops, they don't have that. So there's my VI over QX. And there's my CI over FX, so it's clearly got to be answer A there. Find the scale factor for this. All right, well, let's take a look at it. The only two sides, since they've told us they're similar, the only two sides that I know that correspond to each other are that 15 and 10, so I just have to make a ratio out of those. Both divisible by 5, so it's 3 over 2, or 2 over 3, depending on how someone had set it up, but the only one it could be is that one. They don't have 2 over 3 listed as an option. What is the length of EH? So I already know my scale factor. What was that? Well, I'll just find it again. I did DC, I don't remember which one I did, but DC over HG. 15 15 over 10 divided by 5, 3 over 2. Okay, they want me to find EH. That's right there. So I'm just going to set up a proportion here. And I'm going to write it with the first one I started with, DC over HG. That has to equal the ratio of any two other sides. Well, the other two sides I'm going to use are this BH and this AD. Now, I put DC on top when I made the ratio out of the 15 and 10. And since I put DC on top, I want to put AD on top for the ratio it's equal to, and then the EH on the bottom. So it is this to this is the same as this to EH right there. Now we already know what the ratio DC over HG is. That's 3 over 2. We found that right up above it here. AD is 24 and the EH is what I'm looking for. Now instead of putting EH, I'm just going to call it X. I can cross multiply here. 3 times X, 3X, and then 2 times 24 equals 48. And I'll divide by 3. It looks like I get 16. Now 16 is our EH. That's what we found right there. So EH is 16. 13, again, we already know our scale factor, DC over HG. This is the same diagram, is equal to 3 over 2. Okay, so that is just this to this. It's the same scale factor for everybody, but this time they want me to find AB up here, so I'm going to have to use the 6. So when I set this up, I've got my DC over HG already. Okay, DC came from the big quadrilateral, so I've got to put AB on top. And then HG came from the small triangle, so I have to put EF on the bottoms because that's also from the small triangle. So you can see you should have DCs from the big quadrilateral, ABs from the big quadrilateral, HG from the small quadrilateral, EF from the small. So I'm comparing corresponding sides between the two triangles. Now DC over HG, we already know that's 3 over 2. AB is what I'm looking for. Again, I'm going to call that X, but EF I know is 6. And I can cross multiply. Going this way, I get 2X. And going this way, I get 18. Divide by 2. X must be 9. Are these similar? Let's go for, see, do we have angle? Angle? Nope, don't have angle. Angle. In fact, I don't have any angles between the two triangles congruent. So we don't have angle, angle. Side, angle, side. Well, I can't do side, angle, side either because I don't have a single angle. Let's check if we could do it with side, side, side. So I'm just going to do, here's how I'll correspond them. This to this, and this to this, and my base to my base. And let's just check those. So here's the pink ones. They're in the ratio of 6 to 8. Here's the red ones, 6 to 8. And here's the green ones, 4 to 6. And if you reduce these, they better all come out to the same number. Otherwise, they are not in proportion. And you can see the green sides come out to a ratio of 2/3. So all the sides are not in the same ratio. And therefore, these are not similar triangles. Problem 15, let's see if these are. I've got an angle here congruent, and they both share angle D up here. And the two triangles I'm looking at this triangle. It's got the green angle and that blue angle at the bottom in it. And then I'm also looking at this pink triangle. It's got the green one and also that blue one as well. Now it's a different blue one, but they're the same measure. And so the pink one and the big green one have two angles in common. They both have angle D in common, and then the two blue angles. So we have angle-angle similarity for this one. Two angles congruent, triangles are similar. Let's see if these are similar. We've got some parallel lines going on here. Note that. See these arrows in them? That indicates these lines are parallel. We've got vertical angles right here. Okay, so those are going to be congruent to each other. Because these parallel lines, we're going to treat WY like a transversal crossing parallel lines, and this angle and this angle would be congruent, angle W and angle Y, because those are alternate interior. So here's our parallel lines. These two angles are on opposite sides of the transversal, so that's alternate. They're inside the parallel line, so these are alternate interior angles, and those are congruent when the transversal crosses parallel lines. So we've got two angles congruent between the two triangles, and so that will be angle-angle similarity, and we know their sides are in proportion at that point. Let's see if these are similar. We've got one angle between the two that are congruent. We just got to figure out what this third angle is in each of these. Find out if we have any other angle that is congruent. Well, the entire triangle, and I'm doing triangle, let's do triangle ABC here. All the angles have to add up to 79, so I'm going to subtract off the ones I already know. I'm going to get rid of the 79 angle. They all have to add up to 180, so I'm getting rid of the 79. That leaves me 101 left. Then I'm going to subtract off this 60. And that leaves me 41 degrees left. So this must be 41 degrees right there. And that makes it congruent to angle E in the other triangle. That's two angles that are congruent between the two. And so yes, we have similarity. 18. Let's see if these are similar. We're going to have to go for side, side, side. So let's just pair them up. Let's see here. We got this side and this side. And this side pairs with this side, and this and this. And let's just check the pink ones here. The ratio would be 16 over, I want to use pink there, 16 over 20. The red ones, I would do 20 over 26, and the green ones, 12 over 15. And then we just reduce these. Divisible by 4. Divisible by 2, I think, is all. That comes out to 10 over 13. And so right away they are not similar triangles. The other one, divisible by 3, 4/5. So it's at 20 over 26. It is not in the right proportion, and so these things are not similar to each other. Let's see if these are. So we're just proving here, if you look at all of these, we're trying to prove that they are by angle, angle, or else we choose not similar. You can see these are all by angle, angle similarity. So let's just find out what this third angle is in either one. It doesn't matter. I'm going to use triangle EOH, or EHO, and I'll start with 100 degrees, and I'll get rid of the 90-degree angle that's inside here. That's this guy, leaving me 90 left. I'm going to get rid of the 43 here. I'm just going to borrow there, giving me 47 degrees left for this angle. Let's see, well, they both have the 90 degrees, but this one's got a 49. There's no 49 degree in the other triangle, so without two angles congruent, these guys are not similar. From 16, see if they're similar. By angle, angle, I'm going to use triangle PQR. And I'll start with 180 degrees. I'm going to subtract off the 80, this angle. Give me 100 left. I'll subtract off the 21, that angle. Giving me what, 79 left, I believe? Yep, 79 degrees. So this must be a 79 degree angle. This one's 78. So it doesn't match up with that one. In fact, K must be, what, like 81 degrees or something like that. So I don't have two angles that are congruent. So these things are not similar either. For this one, we're going to have to go by either side angle, side, or they give us angle, angle as a choice. Well, we can't do angle, angle because we don't have a second angle. We know they have the 71 in common. So let's go for side angle, side. So there's the 18 to the 27. We'll compare that ratio. and the 8 to the 10 to see if they're the same. So here's the pink ones. 18. That's not very pink. Let's erase this and start again. So the pink sides would be 18 to 27. Divide by 9, that's 2/3. The purple sides are in the ratio of 8 to 10. Divide by 2, that's 4/5. The sides are not in proportion, so these are not similar. 16, we got an architect here. He's building this bridge. So let me illustrate place where a ravine, the size of the ravine, the road surface. So here's our road surface. And AC then is like the roof that's going over it. And then your ravine is this part right here. This is like the edge of the ravine, and the car looking at it from the edge, and the cars are going across the road right there. Okay. And they want us to find out, would the measurements that they have shown ensure the roof is parallel to the road surface? So what we want to check here is this top to bottom ratio. We've talked about it a lot. We're going to compare top of this triangle to this bottom section and see if that ratio is the same as this top to this bottom. In other words, we're checking to see if this line right here has cut these two sides in the exact same proportions as each other, or in the exact same ratio as each other. If it does, then we know that blue line is parallel to that red line. So let's find out. I'm going to do the black ones first. So 35 is the 14, top of the triangle to the bottom. Okay, think of this as being the peak down there, and that would make 35 the top part of the segment that's been cut. And we're going to check to see if that's equal to that blue side. The top of it is 30 to 10. And if they are exactly the same ratio, then that line, blue line, is parallel to the red line. So divide by 7 here, that's 5/2. And the blue ones divide by 5, that's 6/2. They are not in proportion to each other. Therefore, they're not going to be, since they are not congruent, that was BF over FA was not the same as BG over GC. The two lines are not parallel. So this would be the incorrect proportions to work that out. They wanted that road and roof to be parallel to each other. What's the length of CG? This little part right here. So we're just going to go top to bottom equals top to bottom. Set up our ratios here. And the pink ones would be 63/21 has got to be the same as 57/GC. Before I did this, I think I would simplify. 21 goes into 63 3 times. So this is 3/1 equals 57/GC. Now I'd cross multiply. 3 times GC has to equal 57. Now if you divide by 3, that's a 57. I don't know why I wrote 56. And divide by 3 on both sides. CGC equals, what was that, 19, I believe. Another sort of triangle problem here. Look at all those parallel lines. They've got the arrows in them all. Okay, it means these sides. When I say sides, I'm talking about this side and this side. It cuts all of them into equal proportions. Okay, now they've given us EF. EF, this segment, is to FG, this segment, as BA, this segment, would be to AG, that top segment. So we'll put AG right there, piece of cake. Same idea, we got CB right here to BA right there. Let's do that in green. Would have to be the same as, the EF is right there, and so we'd have to use DE for our blue one. DE Walkers in the park had different benches where they can stop and rest. How far is it between bench A, which is right there, and bench C, which is right there? So what we're going to do is we're going to figure out this distance, AB, by setting up some ratios. We're just going to go AB, the top part, to BC, the bottom part. That's this BC, would have to be equal to, and they didn't label these right here, so we're just going to use 210 for the top part, and we'll use the number 336 for the bottom part. Okay, now BC we do know is 536, so let's do a little substitution. AB over BC, 536, equals 210 over 336. And I'm trying to figure out if there's a number I can reduce that by to make it smaller, because I don't want to multiply such big numbers together. So I'm going to take 210 over 336. I'm just going to start to simplify it. Divisible by 2, 105 over 168, I believe. Let me check that. Yeah. See, those are both divisible by 3, 35, and 56, I believe. 56, 7 times 8 is 56, so they're both divisible by 7. So I think it's 5/8 it simplifies all the way down to. Let's see if we get the right answer when we do this. So I just reduced that fraction. Now I'll cross multiply. 8 times AB equals 536 times 5. So I can multiply that out and divide by 8. I wonder if 536 is divisible by 8. 6 times 8 is 48. I think so. I'm going to divide by 8 on both sides. And 8 goes into 53 6 times. And 8 goes into 56 7 times. So I think it's 67 times 5. 5 carrier 3, I think it's 335, right there. Now they want the distance from A to C, so you've got to do 536 plus 335, and I'm getting 871 for that total distance between A park bench and C park bench. And then our last problem, find the value of x. Note this angle bisector up here. Now you did be careful. We got to figure out how long this little section is. But they tell us the entire thing is 52.5. If I subtract off the 37.5, that tells me this little section is 15. Okay, and then we can go split to split, so 37.5 is to 15, as since 37.5 came first, I have to put x on top, and then the 17 on the bottom. So split to split equals side to side. Then we can cross multiply these, so I get 15x equals 17 times 37.5. Now I'm going to grab my calculator for this one because it just seems like quite a bit of math there. So 37.5 times 17. 15x equals 637.5, and now we'll divide by 15 to get the x alone. And I come up with x is equal to 42.5, and that's what they wanted us to find. So there's your test in a nutshell. Make sure you've watched it, then you can take the retake of it, hopefully improve your score. This is the type of work, though, when I say show your work, you should have work that is similar to the work that I've been showing on these problems.